Hey guys, so this is our C2450 exam one review session. So exam one, it will cover from the book section 2.1 to 4.4, and it will include two free response problems and five multiple choice problems. Two free response problem, according to his email, includes 3D resultant force, which includes the dot product, and also a 2D equilibrium problems. And the five multiple choice problem, he didn't say uh, like specifically what kind of problem is going to be the multiple choice, but he only mentions from 2.1 to 4.4 in the textbook. So I predict that it will be probably one 2D resultant force. I mean, all those predictions just based on my experiences in the past few semesters work as an SI. Normally, that's the type of the problem he will put on as a multiple choice problem for the exam one. So 2D resultant forces are probably going to be there, and you're going to utilize parallelogram law. And for parallelogram law, you probably use the law of sine and law of cosine. Okay, and then 2D moments, and then moment about a point where you have to utilize the cross product. This is a 3D moment problem. And then the last two I predict it will be position vector or unit vector problem and another 2D equilibrium problem, but maybe focus on more like either pulleys or spring. Okay. And some of the test tips that I want to share with you guys is that ask question um, before you start working on the test. So if you see something that's not right, ask them the question because you don't get much of time um, to work on for each problem. Like think about it, you only have 60 minutes for 8 problems and two of them are most a free response problem, which that's going to take a lot of time. And focus on higher weighted and quick questions. So if you see a multiple choice problem that you can just use one formula to solve it, then do it. Or I would suggest that work on the free response problem first, because that's going to weigh heavier, and also that's where you're going to spend most of the time at. And also for the multiple choice problem, don't guess it. He will not give you any points if you guess it, but if you work it out, you show him the steps. Even if you get the wrong answer, he will still give you half of the credit. Like he just want to see that if you are working towards the correct answer. Okay, so never guess a multiple choice problem. Always work it out. So get as much points as you can. All right, and here are just some of the concepts. Like I went over all those concepts in my previous SI video, so I'm just gonna quick going through this and not gonna get into too much detail about it. If you want to know more detail about all those concepts, please go back and watch all my previous SI videos. So for 2D resultant force, okay, like I said, it's gonna be parallelogram law, where you have to utilize law of cosine and law of sine. And we know that we use law of sine when three of those parameters are met. And same thing for law of cosine. We can only use it when we know the smallest angle between two vectors. Okay. All right. And then for 3D vectors, uh, for 3D vectors, there's going to be a coordinate direction angle problems. And for coordinate direction angle, if you have one of the angle that's missing, then just utilize this equation right here because when they are summed all together, they'll be equal to 1. Okay, and then how to find the coordinate direction angle after you find out your resultant force. Just apply this formula right here, where alpha, beta, and gamma is equal to cosine inverse of their force component divided by the resultant force. And then position vector, like I said, RAB will be equal to RB minus RA. Okay. Unit vector, same thing. Unit vector is equal to position vector, which is just this one, position vector, divided by the magnitude of the position vector. So after you find out this thing in a Cartesian vector form, turn that into a magnet. Turn that into a magnitude form, and you guys know how to do that. And then the smallest angle between two vectors. Okay, so this equation right here, where theta is equal to cosine inverse, okay, of those two forces, let's say force A and force B vector, divided by the magnitude of force A and magnitude of force B, and that's how you find the smallest angle between them. Okay, so this is the smallest angle between them. So, and somebody might ask, what's the largest angle between them? Well, if you consider that, oh, my bad. If you consider that this is 180-degree flat horizontal line, then if this is the smallest angle, then this will be, let's call it phi. Phi will be the largest angle between two vectors. Obviously, we don't want to find the largest angle, we want to find the smallest angle, and that this is formula that you're going to apply. Okay, and then for equilibrium type of problem, first thing, always draw your free body diagram, show and label all the forces, label all the unknowns and the direction of the unknowns. I would like for you guys to assume that all the forces going in tension direction, okay? I mean, you could assume that that's going in compression, but in compression, then the sign will have to be negative. I mean, at the end of the day, you're still going to get the same answer, right answer, but we obviously don't want to work with negative numbers. So assume your force is going in the tension direction. And then for springs, we know that spring force is equal to the K spring constant multiplied by the total stretch length, which is S, and S is equal to the stretch, I mean, my bad. S is difference between the stretched length and the unstretched length. So it'll be L. So L after the total length after it's been stretched minus L now, which is the unstretched length. Okay, and from pulley, we know that in this course, we always assume a pulley is frictionless, which means that T1 will be equal to T2. Okay, and there are only two equations for equilibrium, which is just summation of the force in the X and Y direction will be 0. 3D equilibrium, which is not our reading, so he's going to put that on the exam. But for 3D equilibrium, you have to bring another equation into consideration, which is summation of force in the Z direction will be equal to 0. Moments in 2Ds, I said moment will be equal to F multiplied by the perpendicular distance. So let's say this is being right here. Okay, and then I apply a force right here, and then I want to take a moment about this point A. Then how do I do it? We know that look at the direction where the force is going to. Force is acting like this to A, right? What kind of movement is this? This is a clockwise movement, right? So at first, I have to assume that either I want clockwise to be positive or counterclockwise to be positive. If I say I want counterclockwise to be positive, that means that my force going in the clockwise direction will be negative, okay? And then multiplied by perpendicular distance. This is the perpendicular distance, not this, because this distance right here is parallel to F, okay? Okay, and then moments in 3D. We know that moments in 3D will be the R vector multiplied by the force vector, okay? And then there'll be Rx, Ry, Rz, Fx, Fy, and Fz, okay? And then so he didn't have a problem for moment about a specific axis. I think in this example, he says moment about a specific point. So moment about a specific point, I want you guys to know that it's always from where the question is asking you to take the moment to where the force is acting, which I'll explain more in detail to you guys later on. We'll work the problem. We have a problem like that. Okay. And I guess that's all for the concepts.